I don't know how it happened, but I just realized that I had not started this stream, and I completed the whole thing I wanted to say, and then I said, and then I saw that I had not started the stream. I don't know how it happened, but this was frustrating, and I'm recording this again, and I'm feeling a little bit angry. But what can we do? We can just go past it. Okay, let's let's just go through everything very quickly again. In the last stream, wow, this is fun. Repeating everything that I have said again. In the last stream, let's calm down, let's do it one more time. In the last stream, what we had done is we had erased, we had, okay, let me just remove this thing. In the last stream, we had made a premise of how we can, one of the ways in which we can reduce the payload of, we can reduce the JSON size, JSON payload size. And the premise was that we can, one of the ways that we can do it is by abbreviating the key or the property names of it. So, for example, if a JavaScript object or sorry, a JSON object looks like first name, whatever your name is, then we can maybe convert this into, we can change the key name and say it is FM, and whatever name. So the hypothesis was that this reduction of key names, the amount of bytes that would be needed for a longer key names would be reduced, in return reducing the JSON payload size. And I didn't know the extent of it. And as I had said in the previous stream, that I had only known about this technique from something that one of our like the lead architect of the company had done for another services in one of the companies that I had worked for before. So I just wanted to see and check it for myself on um, how much effective this technique is. And it turns out it is very contextual. But in most cases, this technique is might not be needed because, as we will see in what I would help us go. What I will show you in a bit is that if it gzip the JSON, like if you use compression algorithms like gzip or broadly, then the amount of reduction that this technique would do is very minimalistic in comparison to the amount of reduction that the compression does. So one of the use cases here could be that if you have a system where compression algorithms are for some reason a bottleneck, and you just need to stream or send the data in its bare format. I can't think of a system that might have this, but it might be possible. Then this is one of the techniques that might be very beneficial, but otherwise not. If the compression algorithms are involved, there might still be use cases which I cannot think of right now. If you can think of, and if you are, of course, watching this video, then you can definitely let me know if you have done something about this, if you have read something somewhere that much smarter people might have done something, and I have not read that yet. But yes, this was just sort of like a fun research project that I just wanted to do, even if um, it is not going to end in me making a tool to be able to uh, prune the keys automatically, which was the original intent. That I will make a tool which will just make this happen for any JSON payload. But anyway, I learned a lot of things while doing this. So let's go through these things. So in the last stream, what I was doing was that let me just plug in my battery. What I was doing was I was trying to make this. Okay, so just a little bit of recap. I had a manually written uh, JavaScript object which had manually written abbreviated keys. So, for example, I had manually written first name FN and then whatever, and then say last name and then your whatever, right? I had manually written this, and I also had a map, sort of like a this is the object literal that I had made for a map because it was just a config file. I had also written the full names of those keys corresponding to these abbreviations, right? So something like this. So what I did was using this map, I first looped over, like I wanted to, this is where we ended in the last stream. I wanted to use this to eject a, JavaScript object. Let me double click here and pull it off above here and then write it down, which would look like first name, right? Your first name, whatever, and last name, your last name, something like this. So, so this is what I intended to do. I had a big JSON object that was had manually created abbreviated keys, and I also had a map of the abbreviated keys for the abbreviated keys map to their full name of the key, which is user readable. And I had to go through this JSON nested JSON object and then convert all the manually abbreviated keys to their readable full keys. And I was struggling in this doing this in the last stream while following this answer that somebody else had given, and I realized that this might have been wrong. Um, I wouldn't go into the details of it, and I had, in my excitement, upvoted this. Now I cannot. Oh, yeah, I cannot unvote this. I cannot unless the answer is edited. This is set for life. So anyway, never mind. I found an easy way to do this. So that is what I'm going to show you. I'm going instead of the first thing is I'm not using manual recursive iteration on this deeply nested JavaScript or JSON object. I am going to use a cool thing, which is that JSON stringify has a second argument, and I talked about this in the previous stream also, which has which iterates basically for us across the deeply nested JavaScript object and will give an access of key and value for each of the iteration that it is making. It includes iterating over JavaScript, arrays as well, because arrays are just basically indexed objects, is what we can say, like, integer indexed or strings which are integers indexed. Never mind, what am I saying? Yeah, they are basically just indexed objects. So and it goes through that as well. And then we can do whatever we want. We basically the return value is of this function is going to be the value of whatever key that we are being passed. So we have a lot of freedom here to do things. So one of the things that I want to tell a nuance is just an implementation detail of this callback function. I would say is that suppose we have a JavaScript function that looks like this. I'll just copy this off here. The first iteration of this will give us a key that is empty, and its value will be the whole JSON object, right? So something like this. So this is where the iteration starts. So what we can do and what we have done is for each of the JavaScript, like the value that we are getting for each key, we check if it is an object literal. And we do this by checking if the values constructor is object. If it is not, then we are returning the value directly. We cannot do anything with it because it is not a key value pair, right? In the JavaScript literal object this constructor is not an object. We cannot do anything with it, so we are returning the value. So this value could be arrays, this could be primitives and everything. But once we know that that it is a JavaScript object like we have in this case, then what we do is we basically loop through. Um, I'm just going to remove this. We use object.entries to get a tuple list of the key value pairs, right? So, for example, for this, we would get something like a list of tuple. First name would be your first name, and last name would be whatever camel case there, your last name, right? And what we'll do is we are going to map over these list of tuples. We are going to call a function that we have written, and I'm going to explain what it does in a bit. We are going to pass our key to it. So we are going to pass our keys to it, and the result of it would be the same value that is we are getting, but the key would be the abbreviated key now. So this will become something like FN and last name. This is what is happening. And then we use object.from entries, which does the opposite thing of object.entries. And I've not thought about performance at all because I just want to get this um, get this done because this is just basically data creation over which we are going to do some things. So we're just still in the creating. We're just creating a sample data for testing purposes. Um, and yep. Okay. Okay. I think I I think I wrongly said some things. This is not what is happening here. Remember when I told you that I have a map of abbreviated versus the full name keys, and I also have the manually written abbreviated keys JSON or the JavaScript object. Forget everything that I just said. All this is doing is uh, we are right until up this explanation. But after that, this is actually like this. And then what we are doing is we are in our abbreviated keys to full dictionary map that we have for abbreviated keys versus their full names, we are just using their full names as the replaced key. So the opposite is happening of what I explained. We have this, and from this we are getting this. This is all that is happening. So after we do this, we do object.entries, and we are going to get an object out of this in this fashion. So basically, this put in object dot from entries is going to give us this object. So long story short, this just creates our data, our full keyed data, right? So now that we have that data, what are we going doing with it, right? So if I just show you the first of all, let me just show you the results of what we are basically trying to do. Now that we have our data, this is our full keyed data. This is how it looks like. We have user readable keys here. For example, data, status, change, bio, delisted, background color, and everything. You can see the whole thing written with like actual English like keys that are readable. Now we have written a function which basically just, and I'm going to explain what this does is it will abbreviate all of those keys that earlier I had manually done. It will just do it programmatically. And then we are comparing the sizes of these two payloads that we have. But before we go to it, let's just quickly see how we are making this. And it's not an important implementation detail. So I'm not going to go into this get abbreviated object a function that is converting this full keyed data into the abbreviated data that we are seeing here. I'm just going to explain the algorithm. I'm not going into the detail of this. The reason is because anyway, gzip and broadly compressions do much more efficient work in decreasing the payload than this technique can do. So I've just used a very bare bones algorithm to make this abbreviated case. Nonetheless, I will explain it to you. I'm going to open the Excalibur, go above a little. What is happening is, first of all, same technique here as well. So I'm again using that same JSON stringify replacer callback function. Same thing, same check if it is an object. Same thing, I'm iterating over all the basically the key value tuples that I get from object entries of the object. And I am manually creating the abbreviated key and then making a whole object from it again and then returning it. So this is what is happening. Very similar to what we have done here. We are just doing the opposite of it. Instead of looking through the mapped versions of our abbreviated keys to their full versions, we are doing the opposite. We have the full versions of keys now, the user readable forms, and we want to make them abbreviated. So this is what the get abbreviated key function is doing. What is it doing? How is it doing? Is this is like it. So first, if I have this key string, whatever the property name is, I'm deliberately making it camel cased, sorry, snake cased. Right, so snake cased key. This is what is happening here. I'm snake casing the key and just replacing the key with the snake case version. So suppose if I have this camel cased key, I'm converting into first name just for normalization purposes, right? And then what we're doing is if the string that we have gotten from casing the key is in fact a camel cased key with the underscore in it, then what we'll do is we will pick up the first and the first and the first characters of both of these uh, different split names that we have in the snake case. So this will turn out to be fn. But we're also keeping a check and a record of, let me make this empty portrait. But we are also keeping a record of all the abbreviations that we are making. So for example, for first name, we have created fn, the abbreviated version of it, the key. So suppose if there is another key that comes in the next iterations, say suppose that its name is first new name, whatever, and I'm just making it up. And because following this rule, it will also have fn as its abbreviation, abbreviated key. We cannot use that because this will clash. So what we do is we start. This is just a very bare bone method to make a unique key. If the keys are same, we start with the first character of the original key and we start appending it here. And we keep appending it up until the time we find that it is a unique key, right? So if it is a unique key, then we will add it. If not, then we will append the last character, the second character onto this here. So this will become an I, right? And if this is unique, then we will use this as its key. So this was not a very important step towards what I wanted to do because when I ran this on my sample data, I figured that there were hardly any keys that went ahead of three characters. So FNF, FNP, FNS. More often than not, it was just three keys, which was from where we were getting the uniqueness of this particular key. But we could have, if this is this could be useful for somebody or the other. And if it is, let me know, and I will research a bit more and then just change this algorithm to be a little more as efficient as possible. So suppose if f and f is not unique, instead of appending the I here, I will remove the f altogether and try the uniqueness with this, and so on and so forth, instead of appending on top of existing characters that we have tried still. So this is what is happening for the snake case versions. But for the keys, for example, last name, if we snake case this, it will not actually convert into snake case because there is nothing to snake case. So similar technique we are using. We just start with the first alpha character, and same thing. We check if this is already in our record somewhere. If it is, then we keep going and appending the next character up until the time we find a unique key name that has not been previously used. So this is how we are getting. Let me come here and go to our app that is running. This is how we are getting this pruned. I keep saying pruned, but abbreviated key names, nested key names that we are getting here, right? And if we have already had a key that has been made before for the same snake case key that we have gotten as an input, it is going to return it. So, for example, for merge targets, there's something called merge target somewhere here around here. So change absolute has merge target and expense ratio has merge target. So if you would see here, a change ratio, I don't know where it would be, but maybe it is this. So empty is for merge target, and if we come here, empty is also again for merge target. So it gets reused. So that amount of deduplicity, deduplicating is there. Anyway, so this was the sort of like this the data creation part of it. So now where we are at, we have a data sample which has keys which are human readable, and one that we have created from this, in which the keys are abbreviated versions. And now if we see the size of it, let's just go and see how much difference does it make. Um, and if we see here, uh, there are two things that are happening. So first, I check for the uncompressed. I should not write bare. Bare might be not very understandable. I should write uncompressed. I'm going to refresh it again. Uncompressed full key. Let's write the full keyed ones first so that we have a reference for the thing that we have done for later. Refresh again. For uncompressed version of the full key JavaScript object, it is of 80.63 kilobytes. When we abbreviate it, it gets 70.61 KB. So let's just see how much percentage that is. It is roughly about 10%. So how much is it? 80.63 minus 70.61 divided by what it originally was, 80.63. I don't even know why I'm going so specific when I already know the answer, but anyway, it is about 12.27427. Oh, let's just do this. Never mind, I'm just too lazy to do it right now. So this is about this much reduction, this much percentage of reduction. But if we see the gzip version, the full key version is 12.42. And the abbreviated version is 11.93. There's hardly any difference because the compression has done most of the things for us. And I don't know how this compression algorithm works, but it would be very insightful and interesting to read about it maybe sometime. Um, about 4% change figure, and that might be a lot for maybe particular use case that you might be having somewhere. But for most of the use cases, at least for the things that are of these amount of sizes, hovering over 1800 kbs, and maybe even I don't know how these algorithm, uh, like the size changes of the compression done, versus the amount of JSON that it is compressing. I don't know how it varies. We could check that as well sometime, but yeah, this is what is happening right now. So let's just see how it is happening. These are my logs. These are full keyed data. This is abbreviated data. Abbreviated data is just basically we are calling that function that we have created, which creates that abbreviated keys data, keeping the values as same. Um, Now, for the uncompressed version, we are just calling getJSON size function, which takes a JavaScript object. I've written a JSON here, which might be misleading, but anyway, we're converting into a JSON object. We're using a new text encoder constructor, encoding it, and finding the length for it. We get the size of bytes of this JavaScript object here, and then I basically copy pasted a npm module called bytes, which converts number of bytes into readable format. So because you are able to see it here as KBs, this is the node module that it is doing. For time being, I've just copied the whole code, originally created by I think P. Holovicek, who is a legend, and Jed Watson, whose company ThinkMill, I think, has created some very wonderful projects, including Keystone JS, CMS, and React Select component. Um, anyway, so this is I've kept it locally for time being. When I would push this code to GitHub, I would directly use maybe ES module version of this library if it's available. Um, so what we are doing, and once we have gotten the size in bytes by encoding the text and getting the length of it, we are just using that bytes utility method to convert it into kilobytes. And that is how we are getting the uncompressed versions of these much amount of KBs. For the compressed version, how we are doing the compression, we are, if I just copy this up, I'm just going to draw it for better understanding. This is what is happening. Let's go line by line. First, we have a JSON or a JavaScript object, whatever. This is what I am referring to when we have created the JSON for it. We create a blob of it, right? So we convert it into a blob, and now, meanwhile, we also make a compression stream. So we have, I think, three different um, compression algorithms we can use: deflate, deflate raw, and gzip. So we're going to use gzip now. We are creating a compression stream here. So imagine that this is the compression stream that we have made. Compression stream. Now, what we are going to do is we are going to stream our blob, like a binary representation of this JSON that we have made. We are going to stream it into this compression stream. So, and imagine that this is some stream coming in somewhere which has the magical powers uh, to convert to compress any stream that might come into it, right? So this is like a perennial stream that is flowing somewhere, and now we are going to stream this blob in this compression stream. And what this is going to do is this is going to give us a version of this compressed version of blob that we streamed, right? And that is what we are getting here. This is the compressed stream. What we are doing with the compressed stream, we are going to give this compressed stream to a response constructor, and we are going to tell us to convert this compressed stream into a blob. So we call the blob method on it, and we are converting it into a blob again. Once we have gotten the blob of it, we are going to get the size of that blob, and then we are going to get the size of it in bytes. I hope I've not done any mistake. in there. If I have, let me know. So this is what we are getting, how we are getting the compressed size, and this is what we are seeing here and here. So this was the whole the whole experiment to see what happens and how can this particular technique, what is the, how does this entail, and how this technique can help reduce the JavaScript object payload size, and by how much. And this is some of course, I've just used one sample size, and I could create a lot of different kinds of um, JavaScript objects of different kinds and then test with it. But this is what I wanted to do with at least one sample JavaScript object or JSON object. Now, I learned a lot of things in doing this. If you see, and as I had explained before, I'm just using modules here, scripts of the type of modules. And I am, for example, in utils, I am importing strings from different places. And in the last stream, I had also mentioned something about a very cool feature that is in all modern browsers now called importmap, wherein we can alias uh, a remote, either a remote or a relative JavaScript source that we might have. For example, for snake casing, I'm using the Lodash snake case utility that we have from the Lodash ES module version. And I have aliased it to Lodash slash snake case. And in utils.js, if you see, I'm just using it like that, as if it was a node module. That is so cool. And then I'm using it wherever I have to, which I've already explained a little bit. So this was a fun little project, and I think this is the end of it. And if you see this, and if you want me to, if you have any inputs that you have done experiments with, or you know about this particular thing much more than I do, then I request you to tell me about it. And I'm going to make this code, like put it in a GitHub repo after clearing up some things. So all I'm doing here is, and it's just a bare bone HTML and JavaScript files. I don't have much CSS going on because we are all doing things in JavaScript only. And what else? And I'm just using if you see the packages, I'm just using a nodemon to execute a simple HTTP server on port 4000, and I have removed the caching for it. Caching by default is for 5 minutes, I think. And I was trying out some different things um, to fix an error that I was getting, but that error was because of some other thing. So I tried using custom MIME types, but that was actually not needed. But never mind about this. This will not be in the code. And yeah, this is it. So after I was done with this experiment, I did something. I went and I just, okay, where was this? I think I might have removed that somewhere. Let me just see the history, and it might be somewhere around here. I'm very close. I can feel it. I can feel it. I can feel it. I think this is it. There are this post like went through some of the different things that one can do in a particular Java framework to reduce the size of JSON payloads. So compression, and he already they I don't know who they are, but they already explain this thing that gzip would do maximum of the thing for you. Shorter field names, they say that using single field character names, just as an experiment similar to what I had done, but with a bigger data set, leads to 72.5% of the original size, basically 26-27% reduction. We saw a 10% reduction in our original size, but when we use gzip, we just saw 4% of the reduction. In this case, they saw that it is just will compress that to 23.8%. That is not much smaller than 25.3% we got from. Basically, they're relating it to like the pruning of, sorry, the abbreviation of the keys only did about like 2 point, how much? Or 2 to 3% of change here with respect to 25 or 24% of the reduction that gzip had done, right? So this might be not a good idea, is what I also came to the conclusion. Like this might not be needed. The compression might be doing the most of the things for you, unless it is very, very required that you do as much as possible to prune the data. Yeah, to decrease the size of the JSON. Serializing to an array, this is one of the interesting bits that I saw. But also the same thing that I wouldn't go into and read the amount of reduction that happened. 53.1% of the original size, that's way lot than the one that we got from shortening the field names or the property names. Moreover, using gzip will compress that to 23. That's not much smaller than. So this is again the same. No, okay. So I'm reading the same thing again. Sorry. 22% with gzip compression. This is our best result so far. Still, 22 is not significant to 25. Still, like they got 3 to 45% from doing converting, serializing their JSON to an array. Excluding null values, I think most of the production apps might already be doing this, so it's not something new. And while just going through this, I realized that I had heard about this, but I had not known about this before. There are other formats other than JSON which are much smaller by default than they are, and one of them is Google's proto buffer. And I had just started reading about it, and I heard about it from time to time, and I had not known how it works, how is it different from JSON, how is it smaller from JSON, all of these things. In the subsequent videos, when I have learned enough about this to be able to share, then I will share that with you. But up until the the intention of these two-part videos was that to just evaluate this particular um, JavaScript, sorry, this particular technique to abbreviate keys and see how it affects the size of the JSON, both gzip, compressed, and bare bones. So it was not a lot, but it was something. So this was an interesting experiment, and I learned a lot about some cool web features that I've landed in the browser that I had no idea about. Like I got to know how to find the sizes of the JSON and how to compress it in the browser itself. I didn't know that was possible. Learned this cool technique, played a little bit with streams and blobs and stuff, and also, of course, played around with the type of module. Bare bones, I had not used this before, and I also played around with import map, which was cool. So that is it about the stream, and I will see you in the next one.